This is an introduction to Chapter 4, which is one of the chapters that's involved in Module 12, and this will be a direct look at primarily directly measuring behavior. We covered part of this back in Module 2, but this will be a more specific examination of direct observation, for example, or directly measuring behavior as part of applied behavior analysis. Obviously, by now you understand that measuring behavior is a cornerstone, the basis for applied behavior analysis. We have to identify important behavior problems and we have to measure them in order to make decisions. In fact, I'd say direct and repeated measurement is a hallmark of ABA. We measure behavior in real problem settings in order to make effective decisions, such as identifying problem behaviors. It's part of a functional assessment, part of setting goals, and critically as part of progress monitoring and changing interventions. We measure behavior so we can be accountable to stakeholders, targets, and goals. This is part of the ethics of applied behavior analysis. We do it to verify the effectiveness of treatments, to collect evidence for evidence-based treatments. We do it because measuring behavior is an ethical standard for behavior analysts. And we have to understand the intricacies of measuring behavior in order to effectively consume behavioral research. I think it's useful to put the role of assessment, of measuring behavior, into the 7 characteristics of applied behavior analysis. So the characteristics of applied and behavioral, we have to have methods to identify and define targets for behavior change and to set goals. We have to identify the relevant factors that may influence intervention planning. In this case, we'll do this through functional behavior assessment. It's part of being analytic, of understanding the antecedents and consequences that influence problem behavior and expected behaviors in problem settings. We monitor progress and make decisions. That's part of being analytic, behavioral, and technological. We evaluate outcomes in order to judge the effectiveness of interventions. We have to determine if interventions are being implemented as they've been designed. That's part of being technological. We have to determine if data being collected are accurate or they actually reflect the behavior of the target person and not the observer. That's part of being behavioral. We have to collect data and measure behaviors to determine if our outcomes are socially important, part of being effective and generality. And again, applied behavior analysis depends on repeatedly measuring behaviors, important behaviors, across time. And when we talk about repeated measurements, we're talking about being able to measure the same thing the same way across time in order to make important decisions as part of applied behavior analysis. It's almost trite to say that in order to measure behavior, we have to define them. I've posted there's a posted video on Blackboard that's very interesting about defining behaviors, and I think if you've not done a lot of this, or even if you have, you know that defining behaviors is more difficult than it at first seems like it would be. The characteristics of definitions can depend on how you're measuring. For example, if you're going to count a behavior, you have to be able to discriminate when it begins and ends. Sometimes, for example, social interactions are difficult to decide when one begins exactly and when one ends exactly. Definitions can't include unobservable dimensions like aggressive, intentionally, on purpose. These are inferred. We don't include inferences in our behavioral definitions. We measure behavior, and from those data we then make inferences. So our definitions might need to describe important qualities like the beginning and the end. Good definitions give examples and non-examples. And again, it's much more difficult than it seems. Take a look at that video on Blackboard. I think it's a pretty good video. It does talk about some of the problems with defining behaviors so that we can measure them. You can look at behaviors as in a functional way or topographical way. You can define them that way. The function of a behavior is the most important feature. In fact, applied behavior analysis depends on understanding how behaviors function. But almost always we define behaviors topographically, how they look. You really have to almost define them how they look, even if you're talking about functions sometimes. Um, Topographical definitions may be simpler and more concise and easier to do. So most of our discussion around this module is going to be around topographically defining and then measuring behavior. But we've still got to consider the function of the behaviors that we measure. So we also may be interested in measuring antecedents to behaviors and consequences of behaviors. And we'll talk a little bit about that. Sometimes that's called ABC measurement, and of course during functional assessment we look at antecedents and consequences. Functional assessment is something that you'll learn about beginning next semester, and then in detail when we have a complete class on functional assessment. What are the measurable dimensions of behavior? Well, dimensions are distinct features. We can measure behavior continuously or discontinuously, and we'll talk about time sampling here in a minute. The three fundamental dimensions of behavior that we can measure: the repeatability or accountability of behavior, the temporal extent, for example duration, the temporal location, for example when behavior occurs. Then we have derivative measures that are not necessarily fundamental. These are things like percentage that are widely used and also in applied behavior analysis. The book has a pretty good discussion about these measurable dimensions. The measures based on repeatability include rate and frequency. Frequency is simply a ratio of count per observation period. Rate is more meaningful than count alone. So if I say that he got in fights 3 times per day, it's much more useful than just to say he got in 3 fights. I don't know if I say he got in 3 fights whether that was 1 day, 1 year, or his entire life. So almost always it's best for counting behaviors to convert those to rate. And we report rate as the number of occurrences per some standard unit of time. You could measure the rate of behavior per second. That's not very easy to talk about. You can measure it per hour, per day, and really the unit of time depends on the particular problem behavior. But that's rate. There are lots of ways to record or count behavior. I just want to bring this up right now. Clickers, recording forms, electronic, etc. And you have to be able to count behavior, obviously, and to create rate. When we talk about rate, we have to think of the complexity of the response as part of that. Extremely complex and lengthy behaviors don't lend themselves to rates. Rates very useful as a measure for free operants, not so much as appropriate for responding during, for example, discrete trial instruction. And it's not as useful for continuous behavior that occurs over long extended periods. Here's an example of a recording sheet for rate. This could be used in a classroom, for example. And you look on the left-hand column, there's a place to put the times or the periods of a classroom day, and then there's Monday, Tuesday, Wednesday, Thursday, and Friday. And this is a simple recording sheet. It could be used by a teacher or a paraprofessional in a classroom, for example. And you just put a mark in the cell where it occurs. You could tally it the typical way of making 4 marks and then a slash for the 5th one. It doesn't matter. You can also get an idea that if something has extremely high rates of occurrence, then rate's not the best measure. Sometimes, for example, self-stimulatory behaviors, stereotypical behaviors as they're also called, can occur at very high rates, 10, 20, 30 times a minute. Those are difficult to count. So we usually are interested in rate for more moderate or low frequency kinds of things, but you have to have some way to record it. Here's just one example. The second measure is based on temporal extent. This is almost always duration. Please take a look at your assigned video on Blackboard. It's the amount of time a behavior occurs. We could talk about the total duration of a behavior in a session. So we could say, for example, that behavior occurred for 4 minutes out of an hour's observation. We could measure the duration of each occurrence. So I could say that a behavior occurred on 5 occasions, and I could list the durations of each of those occasions. And we're going to report those in standard time units. The count and duration measures provide a very different picture of the same behavior. So one of the things when you're deciding about measuring behavior in applied settings is what are you most interested in? The percent of time that it occurred, or are you interested in the number of times it occurred? Even to think about the same kind of behavior, I'll use my experience. For example, out-of-seat behavior. Is it the number of times a kid got out of his seat without permission? Or is it the total duration of time he spent out of his seat without permission? He could get out 20 times in an hour, but just be out for a second. Or he could get out one time and be out of his seat for the entire hour. What are you mainly interested in? Or, if you're interested in both, how would you measure both? We can also be interested in measures around temporal locus. Response latency is a typical thing here. For example, of a measure of elapsed time between someone giving a person an instruction to do something and they're beginning to comply. That can be important in some settings. Also latency in responding to questions. At any rate, it's typically reported as a mean, a median, or a range of latencies. So again, we're just talking about the possible dimensions of behavior to measure, and this is again something that you must seriously consider when you're talking about taking on a project. What are you interested in about a behavior? Are you interested in rate frequency? Are you interested in duration? Are you interested in temporal locus? Today, with the advent of computer-assisted observation becoming more and more prevalent, it is sometimes possible to measure more than one of these at the same time. Another measure for this dimension would be inter-response time. It's the amount of time that lapses between two consecutive instances of a response class. So how long between tantrums? That would be an inter-response time. How long between classroom disruptions? You will find out that sometimes measuring inter-response times is critical for designing an appropriate intervention. This will be also reported as a mean, a median, and a range. There are a number of so-called derivative measures that are very important. We don't always count behavior or don't always interested in the temporal location, but sometimes we're interested in measures like percentage. For example, the percent of items correct on a test, the percent of steps in a dressing skill, for example, the percent of steps formed correctly in putting on a coat. I've used both of those as measures, so we would task analyze something, break it down into steps, and we could measure the number of those steps done independently by someone without a prompt. So derivative measures like percentage, percent of correct and incorrect are important, and they, if things are defined correctly, can be very useful. A very common type of measurement used both in applied settings and for research is the idea of time sampling. We've read some articles already this semester, and you read more subsequent semesters that use time sampling as a measurement technique. So we want to talk a little about the common types of time sampling, and your book does a good job of discussing these, and there are some videos posted on Blackboard that talk about these and show examples of these also. With time sampling, we're interested on selected aspects of behavior as they occur within specific intervals. So for example, we'll define an entire observational period. Let's say we're going to watch someone in a community setting for an hour. We might break down that hour into much shorter intervals of time, for example 15 seconds. And every 15 seconds we might record whether or not during any of that 15-second interval the behavior was occurring. That's called partial interval, by the way. But we're looking at, by some definition, during these brief intervals, is the behavior present or not. And how we define the presence depends on the type of time sampling that we're using. There are three types of time sampling: whole, partial interval, and momentary time sampling. They all involve dividing up an observational period into smaller intervals and then sampling whether or not, by some definition, the behavior occurs in each of those intervals. These are all called 1-0 systems. We score 1 if they occur. We don't score anything if they don't occur. It's the rules for scoring 1 that defines the type of time sampling. Here's an example of a recording protocol for a time sampling system. This is called the State Event Classroom Observation System. It uses a 30-second momentary time sampling, and so each one of these columns represents a 30-second period. On the left-hand side, you'll see letters. SW stands for seat work. That means the kid is engaged appropriately at some work at his seat. LK means looking around, OAT, other activity, SIT, social interaction with teacher, and so forth. The way this would work is that every 30 seconds you'd have something that would cue you, like an earplug with a chime, and it would chime, and at that moment you would ask yourself if any of these behaviors are occurring just then. If they are, you would mark a 1 in the appropriate cell. So for example, interval 1, if the timer would go off. If the kid was engaged in seat work, I would put a 1 in that one. And if he was engaged with the teacher in seat work, I would put a 1 in that one. So you could score some of these together and some not, but each time we saw a 1 in a cell, that would mean that by definition, when the timer went off, the 30-second interval chimed, I'm going to say, is the behavior there or not? I'm sampling the behavior across time. And the definition of marking the 1 is it's occurring at a particular end of a particular interval, in this case 30 seconds. It could be any length of time. It could be 5 seconds, 30 seconds, 5 minutes. So here's the rules for scoring 1. Partial interval, let's say I had a partial interval 30 seconds. I'm going to watch, and if any time during that 30 seconds, if at any time during that 30 seconds the behavior occurs, I'll mark a 1. Whole interval, I'm only going to mark a 1 if the behavior is happening the entire 30 seconds. Now I just defined momentary time sampling on the last slide. If it's occurring at the exact moment at the end of the interval, I'm going to record it. So those are 3 definitions for recording 1. Partial interval, whole interval, momentary time sampling. All of them are 1-0 schemes. Interval recording is obviously most useful for overt behaviors. Of course, we have to be able to see things. They're useful for behaviors that don't have a beginning or an end, because all I'm going to do is sample them. They're good for behaviors that occur with moderate frequency, although they could be used with high frequency behaviors. Partial interval could be at any rate. Whole interval, momentary time sampling might not be. But they're not suitable for recording the exact frequency or duration, and they're not going to give necessarily good estimates of frequency or duration. But they're quite useful in repeatedly measuring behaviors across time. Time sampling also allows us to observe multiple behaviors at one time, provides a good structure, provides a way, which we'll talk about later, for checking the inter-observer agreement or reliability of observation. It's applicable to a very wide range of behaviors. Doesn't provide much information about the quality of the behavior, just whether or not it was there or not. And sometimes, for example, whole interval collection underestimates the occurrence of behavior, and partial interval may overestimate. This is discussed in your textbook. So there's advantages and disadvantages as to what kind you use, but they remain widely used in things like functional assessments, functional analysis, and in planning and progress monitoring behavior problems in various settings. Momentary time sampling is very easy to use. It's very useful for multiple behaviors, adults or children. It's applicable to behaviors without beginnings or ends, and it's the least biased if you're going to compare it to whole or partial interval. But it may miss occurrence of brief, rare responses, and the continuity of behavior can be lost. So there's again advantages and disadvantages. Remember, your intervals can be any length. Typically speaking, the shorter the intervals, the more accurate, if you will, the more reflective of behavioral qualities these schemes will produce. But that will also be discussed somewhat in your book. One issue about reporting interval and momentary time sampling is that we don't report that behavior occurred some percent of the time because we're not measuring the actual duration. We're not even, under many conditions, being able to accurately estimate duration. We're simply going to have to report, this is the statement, the last statement, student displayed, and you would say the percent of intervals that the behavior was present. So Bobby's tantrums were present in 15% of the intervals. And as long as we do it the same way repeatedly across time, then we can make decisions about the presence of behavior and about behavior changes. We just don't want to mislead. We're not actually going to estimate any of the real-time dimensions of behavior, but we're going to be able to nonetheless usefully measure behavior. Another useful way to measure behavior is by permanent product. This is widely used in academics, for example. The percent correct on a test, the percent correct on a homework assignment, or any behavior that leaves some effect on the environment, like writing. can be measured. You could actually have studies done about reducing litter, where the number of pieces of paper that was left on the ground is measured. So that's permanent product. Select have a way of recording it, and it can produce different kinds of things. It could produce an actual count. It could produce a percent, which is a derived measure. But we often may use permanent product measurement in applied behavior analysis. It's only a brief description of electronic measurement in your book, but I put a link on Blackboard for you to go to a developer's page to take a look at an app for an iPhone or an iPad. Tremendous possibilities of electronic measurement for tablets, for smartphones, for iPods, etc. Links on Blackboard. It also presents great opportunities for direct graphing from electronic files, for ease in file storage, for standardized observation, for example, within an autism program. It also presents great challenges. It appears, it seems so easy, but you still have to worry about things like the accuracy of observation, about behavior definitions, about inter-observer agreement and stuff. But I think it's foolish these days not to have some familiarity with the use of software and technology as an aid in measuring behavior.